All right, people, let's talk about indoor environmental quality. 16 total credits, not a huge credit category, but about half of them, or maybe more than half, are all related down to indoor air quality, and then there's everything else. So we're going to do two videos. I'm going to focus on air quality in this one. So let's look at what's the issue with air quality indoors. There's all sorts of things that make it kind of nasty for us, from molds and mildews to pollens to chemicals, food, dust mites, pets, all this kind of stuff. So it's important. How come? Good quality indoor environment leads to healthy, productive employees and students, and those have been studied over and over again that is in fact true. So, and it keeps us happier. So, part one, indoor air quality. The intent is to have a safe, productive environment for the occupants. A prerequisite to control the tobacco smoke, have a minimum level of adequate ventilation, and that doesn't mean just opening windows. It means, number of air changes per hour, that sort of thing. Trying to avoid chemicals from cleaning supplies, automotive, copy rooms. You never think of photocopiers as being that nasty, but they really are. Prevent carbon dioxide, avoid volatile or organic compounds, similar we've talked about in some of the other credit categories, and controlling construction dust. So first, the prereq. Smoking should not be allowed in the building and only at least 25 feet away. Pretty straightforward. Adequate ventilation. We have to meet ASHRAE 62.1. I think 2016 may be old at this point. There's some newer ones, but that's the idea there. You can either do mechanically ventilated, naturally ventilated, or both. Doing both requires a lot of sensors, because how do you know when somebody opens a window and takes the whole mechanical system out of balance? And you have to do air quality monitoring to see if it's actually working. So similar to some of the other credit categories, we have a baseline case. This is the prereq that you have to make at least ASHRAE 62.1, minimum air quality performance. So that is for mechanically ventilated spaces, it's ASHRAE 62.1. If it's naturally ventilated, then we switch to the Certified Institute of Building Services Engineers, the CIBSE. So improving over that minimum, we can get more credits, up to 2. By optimizing the mechanical systems, using operable windows for natural ventilation, stack ventilation. We'll talk about all this in more detail, or using a mixed mode with sensors to make it work. So what's this stuff look like? These are doors that are the size that you and I could walk through, except they're confined spaces. But this is an air handler in the Colby College Athletic Complex that I worked on a couple years ago. As an example. So stack ventilation I just mentioned, by designing the building with these sorts of shapes where cool air can come in at the bottom and ventilate at the top. So the warm air rising will pull cool air in, particularly if you do this in the evening when the temperatures are lower. This is a good idea. Higher ventilation rates. The typical U.S. building code is 15 to 20 cubic feet per minute per person. If you can bump that to 20 to 25, it's better. And that's part of this enhanced air quality strategy. MERV 13 or higher filters. MERV is the minimum efficiency reporting value. And the higher the number, the smaller the stuff it filters out. So you can see kind of on the left end of things, wood burning smoke, tobacco smoke, insecticide dust. On the right end, larger things that you can filter out with a MERV 8, dust mites and pollen, stuff like that. Usually a combination of filters are used. There's a couple of examples of HRVs, heat recovery ventilation systems, so that you're sending warm air out the wall, which is mixed somehow mechanically with cool air coming in, so the cool air coming in recovers most of the heat. I've got different videos that demonstrate that too for the system I put in my own home. But if you're getting to the commercial scale, this great big box up here is part of the HRV system. It's a big flapper valve that switches back and forth so that warm air heats up some media on the way out, and then it flips and warms the air coming in. Or you can do what's called an energy recovery wheel. You can see you've got cool air going out the bottom and warm air coming in the top, and they exchange in this wheel that turns slowly. Pretty simple mechanically. How about some enhanced indoor air quality strategies? Isolating exhaust from vehicles, garages, housekeeping, any sort of nasty things, that seems like a no-brainer. Monitoring carbon dioxide. So like classrooms, where you've got, sometimes you got a lot of people and sometimes you don't. Having CO2 sensors, you can turn up the amount of air being ventilated when you've got a lot of people in it, but then when it's not so occupied, you can turn it down. Dirt traps and entryway systems help. Those are the kind of things that we definitely don't have in Boardman Hall, but here's a picture of one where as you walk in, you knock the dirt off your feet so that it doesn't spread throughout the building. This is at the Colby College Athletic Complex. It's the frames for a dirt trap, so you can see how it's below the floor. It has to be cleaned out regularly, but again, helps prevent dirt from accumulating around the building. Another strategy, low-emitting materials, similar to materials and resources. Low VOC products, the paints and sealants, carpets, flooring, composite wood products. And if you get into the healthcare and schools certification systems, then it's stuff on the outside of the building. Up to 3 credits for that. Some examples. Regal waterborne interior paint. Most of the paints now are low VOC or zero VOC, I should say. And then if any of you have ever worked with PVC cement doing plumbing, that stuff is pretty stinky. But apparently there is this Gorilla stuff that is very low VOC, so I haven't tried that yet, but something to think about. Construction indoor air quality. You got to have a plan to manage that using the SMACNA Indoor Air Quality Guidelines, which is the Sheet Metal and Air Conditioning National Contractors Association, because the ducts are the huge part of that. Keeping the construction isolated, you see plastic sheeting and stuff like that. Duct work, as it's brought into the project, should be sealed up during shipping and not unpacked until it's ready to be installed. During construction ventilation, of course, it's nice for the health and welfare of the construction folks to have appropriate ventilation at that time too. And be careful of stuff that might absorb water and get moldy. All these things help the future quality of the building and air quality. Assessment, so you got to check and see if it's actually working. Do some flush outs, basically run a lot of air through the system and clean it out. Replace the filters, run it hard again so that your ducts look like the right hand side of this picture instead of the left hand, which is what they normally look like. Green cleaning is also a good thing. Keeps the chemicals out of the air and stuff, particularly for operations and maintenance. Not such a big deal with the small stuff, but if you've got floor cleaners, floor finishers, and strippers, those can create a significant stink. If you've ever been in a classroom in Boardman, after the floor crew has come in, you know that they have a pretty strong smell. And finally, the last piece of air quality is pest management. Again, much more important in operations and maintenance, trying to cut down on the pesticide use and stuff. Here's a screenshot from the National Pest Management Association, which offers some good resources on that. So that wraps up the indoor air quality. We'll do the rest of the environmental quality in a separate video.